Hello everyone. This video introduces the section analysis function. This function is based on measured data to obtain the measured sections at each location or the real terrain undulation. It can edit and manage the measured sections, and finally output the information of each section. The section analysis function. It can analyze both road and other terrain scenarios, but also for tunnel scenarios. This video is based on two tunnel data to introduce the section analysis function. Activate the section analysis function under the My module. Start editing. Select measured data and design data. It supports both point cloud and mesh data types. Among them, measured data is mandatory, while design data is optional, but only by selecting design data can we generate the real section to perform the analysis. At this time, the functions of the section analysis toolbar will be activated. The first step in section analysis is to prepare the reference longitudinal section. If there is already reference section line data, you can directly import it from outside, which supports TXT, DXF, and SHP formats. If not, you can also draw section lines directly in the software. First, draw the center line, which is the reference longitudinal section. Activate the Draw Central Axis function. Manually draw the reference longitudinal section along the road center. Double-click the left mouse button to end drawing. Then add the reference cross-section. Cross-section is a cross-section perpendicular to the reference center line. You can add cross-sections automatically or manually. To add cross-sections, when automatically generating cross-sections, you need to set the corresponding parameters. If you don't know the left and right widths, you can directly use the measurement tool in the software to measure. Set the starting mileage to 5 meters here. Start mileage refers to the starting mileage of generating the reference cross-section. The mileage value of the cross-section is accumulated on this basis. Check Create Section on Node. It will create cross-sections at the nodes where the center line is drawn. To create cross-sections, check Create Sections by step. It starts from the starting mileage to create evenly distributed cross-sectional lines. By slope, it creates cross-sections based on the elevation differences between the centerline nodes. You can choose the appropriate construction method as needed. After setting the parameters, click Apply. If the construction is wrong, you can choose to clear the section line. If you want to add additional cross-sections after the construction is completed, you can choose to manually create a cross-section. You only need to set the left and right widths, and you can add cross-sections at any position on the longitudinal section. You can choose to save the constructed reference section line for future use. It supports saving as TXT, SHP, or DXF format files. If needed, you can also use the Extract Points Along Sections function to extract the point cloud around the reference line. After building the longitudinal and cross sections, based on the section line to generate a road or tunnel section diagram. Here, select to generate a tunnel section view. Click Calculate. Set the parameters for generating the measurement section. Then the software will analyze the section based on the survey section. You can select from the list. Select one or more reference lines for generating sections. The default is to select all. It should be noted that for tunnel sections, the centerline does not generate the measurement section. The 2D option. It means all points in the Z direction are involved in the calculation. 3-dimensional means only the points within the Z range are used for parameter calculation. Here, the default is 2D. Max edge length refers to the largest side length value into which the generated measurement section can be divided. If the distance between 2 points in the section is greater than this value, it will be divided into 2 parts. The larger the value, the fewer real section points will be retained. Section thickness is used to extract the point cloud. To extract the range of thin slice point clouds, These point clouds will be used to calculate the real section. When the point cloud is sparse, to better preserve the details of the measured section, this value can be appropriately increased after parameter settings are completed. Click OK. You can see that based on our reference section line, the software generates a real section line that fits the ground. In the section view in the window, you can compare the measured section with the design section. The red line is the measured section generated based on measured data. The green line is the design section based on design data. Black is the point cloud. In addition, you can also choose import a parametric tunnel section as the design section. It supports 4 types of tunnel design sections. It combines the section comparison function to generate the corresponding section comparison diagram. In addition, the software also provides the function of editing section line nodes. Edit the nodes of the tunnel section line. After enabling editing, you can drag the nodes, which is used to edit all noisy tunnel boundaries for editing. You can also choose to add or delete nodes, or directly delete the line on the section. Users can use the export section function to export the current generated section line. It supports exporting to CSV, SHP, DXF, XML, and other formats, and can be saved as one or more files. When exporting the tunnel section, you can also choose whether to export section trajectory. The section trajectory is a CSV file, which records the center pile's direction and the top plate's coordinates. Set the output path. Click OK. Based on the export image function, you can save the section view as a PDF file. In the section manager, by double-clicking on a section, you can go to the corresponding section view. At the same time, the attribute information of this cross-section will also be displayed in the attribute bar below. In the attribute bar below, including the basic information of the cross-section, the height and width of the measured section, its area. The information of fill and excavation is based on the section comparison function. The generated reference section of the tunnel and the tunnel design section are compared, and calculate the fill and excavation area and volume. Set parameters. Click OK to generate. After generation, the fill and excavation areas are displayed in different colors. The color can be changed in the settings. Meanwhile, the fill and excavation attributes in the section manager have also been updated. In addition, the software also provides the function of exporting reports. You can export the cross-section and cross-section information from the current window as a report. And you can also set the report name, company, and author information yourself. Both HTML and PDF formats are supported. This is the report of section comparison analysis. In addition, the software also provides length and area measurement. Tools can be used to measure directly on the section. It has the display tracking line function. It can link the section with the point cloud in the view. It can locate in real time according to the position to view the real situation of the tunnel point cloud. In addition, the software also provides a section quality inspection function. It can check the current section or imported section for inspection. Imported sections only support HDM format. Check the items that need to be checked, and set the output path. It should be noted that, in the output report, only the sections with problems will be listed and items without problems will not be listed. In the section analysis toolbar, V9 has newly launched a section change analysis function, which is used to obtain the cross-sectional change analysis results and analysis charts of 2 sets of point clouds over a fixed mileage section. Step refers to the fixed mileage segment used for cross-section change analysis. You can also set the report name, output company, author, and other information yourself. Finally, set the output path. Click OK. In the section change analysis report, First, the summary information of measured data and design data. Then, the parameters are set. Finally, there is a list of change analysis for different sections, which includes the basic information of the section, the maximum difference map of the area, and the statistical information of the corresponding position. This is all about the My modules, or the introduction of the section analysis toolbar. Thanks for watching.